Today we're going to talk about evaluating powder coatings and their physical characteristics. At the Innovation Research Center here in Houston, we have a lab that's fully functional and evaluates a variety of different elements of any powder coating product. What we're going to do is just kind of walk through some of those with you so you can see not only how we perform the tests, but how we evaluate the results. We're going to look at impact resistance, direct and indirect. We're going to look at conical mandrel, a flexibility evaluation of a coating. All of these things can help us understand how they will perform in a specific environment. So let's go to the lab and look at those applications. So in this particular test, what we're doing is we're evaluating partially the flexibility of the coating. This is called an impact test. And in an impact test, what you do is you take the panel and you determine the amount of inch-pounds that the material will take. In this case, what Van's doing is he's setting it up all the way to the top, 160 inch-pounds. As he drops it, he then takes out the panel to evaluate whether or not the coating cracked. Now that was a direct impact. When he turns the panel over, which is on the back side of the panel, we're evaluating the indirect impact. Both of those give us an idea of flexibility and adhesion to the surface. The first panel that Van's looking at passed 160 inch-pounds direct, which is the top indention, and 160 inch-pounds indirect, which is the bottom indention. This panel that he's going to pick up second, marked 1003, failed. It failed direct and indirect, as you can see by the rings on the direct impact, and you can see by the spider webbing on the indirect. So this is conical mandrel, and as you can see, there's a conical shaped device that bends the panel starting with a very, very tight radius into a larger radius. What we're evaluating here is the flexibility of the coating and how it adheres to the surface of the panel. This is a test where we're actually evaluating the adhesion characteristics of the panel. So in this case, we're spraying up a couple of specimens. We'll cure these panels and then we'll run them through what we call crosshatch. When you evaluate crosshatch, what we're doing is we're taking a series of blades and we'll cut in the vertical and then we'll cut in the horizontal, all the way down through the coating to the surface, creating a checkerboard. Some of the coating actually comes up through this process, and so we'll brush off the excess coating that's peeled up from the cutting device. After that's done, then we take a specific tape and we adhere that over the crosshatched area. There's a device that we use to make sure that we get very good adhesion to the coating. So we press down on top of that tape to make sure that all of the squares are covered. After we're sure that's done, we'll pull the tape up and we evaluate it in three different areas. Number one, we'll evaluate the back of the tape itself to see if there's any lift or any of the squares have come off onto the tape. And then we'll physically look at the squares, the checkerboard, to see if there's any squares or even pieces of square that might have been removed or lifted. And we can look at it under magnification just to assure that we're not missing a corner or a small piece. If nothing is lifted, as in this case, that passes a 5B, 100% adhesion. These are just some of the tests that we can perform at the Innovation Research Center here in Houston. There are many, many other things that we can do to evaluate coatings. Stay tuned for our next video.